morning, everyone.
Morning. Oh.
Sorry, that was a little loud. So we're going to share with you some ideas and experiences about enhancing enterprise capability through core use case integration. We're going to cover what makes a core use case, what are the core use cases, and how they work together to enhance core processes. So what makes a core use case? First, the pain can be clearly defined. The value is able to be quantified, and Auros can solve the pain in a unique manner, which can be differentiated from other solutions. So today we have 6 core use cases defined. We're going to talk through 5 of the 6. Jeff Moffa is going to do a presentation on compliance this afternoon, so we won't cover that one. The first use case we'll talk about is lessons learned. Lessons learned are the learnings gained from the process of performing a process or an activity. We document lessons learned to share and use knowledge derived from experience to either promote the recurrence of desirable outcomes or prevent the recurrence of undesirable outcomes. So when we look at the maturity of lessons learned process, we see that they go from capture-centric to reuse-centric. In an ad hoc lessons learned process, lessons are disorganized, unfiltered, and can have multiple formats. So there may be lessons in PowerPoints, Excel sheets, stored on local drives, and not necessarily shared or reused. In an organized process, those lessons are managed, but they can vary. So you can search for them, but they haven't been reviewed, and they're not necessarily all relevant. There's not an obsolescence process. This may be a more organized document-based solution, such as a shared Excel workbook. The next stage in the maturity of lessons learned process is enterprise library, where you have consistent, organized, and relevant lessons, but you rely on manual searching for the reuse. This is where we start to see software-based solutions that are well organized, but the lessons aren't actively being applied. In the final stage of maturity and lessons learned process, we have knowledge-aware approaches. So the lessons are consistent, organized, and relevant, but are now also provisioned within the flow of work. Lessons are standardized, they go through a promotion process, and they're actively applied through assessments, and then obsolescence is supported by data. So looking at the lessons learned functional model, we see that first lessons learned are sourced through things like problem solving and after action reviews. Next is the promotion process. So not every lesson or item that you learn becomes something that's reusable. This can be done inside or outside of Auros, depending on your process. And at this point, and after you've promoted a lesson, you get to the library or life cycle stage. And at this point, we've reached the enterprise library maturity stage. In a knowledge-aware approach, the last step is to push and read across lessons. So either you're in flight on a project and you want people to see something that comes in and be able to apply it, or there's on-demand reuse, so you can provision these lessons as needed. And this lessons learned process can be done within the flow of other processes. So if you're in a design review and you learn something, you could kick off your lessons learned process, go through this flow, and then continue within the flow that you were working on.
Hear me? All right, perfect. No? We'll raise it up. Is that better? All right, perfect. All right, so I'm going to share with you our use case for requirements. Now, I have to say, out of all of the use cases, this is by far my least favorite one to talk about. And kind of for good reason. As a lot of you know, you've known me for a long time now. I've been around the company for quite a while. And early on, I really struggled to spread the message of requirements. I had a lot of negative interactions with customers over, what are requirements? And basically, it just boiled down to a communication issue. And the thing about requirements are, the requirements can be so vague. Everybody kind of knows what they are, but the way they're applied and the way your organization or the way you're familiar with them isn't exactly what other people do. And so for me, when I first started talking about requirements, I was very uncomfortable with it. And so it's kind of funny that Mikayla asked me to present this one because it is my least favorite, but I want to share some stuff with you. There's a lot of things I've learned over time that makes this a very valid and useful use case to talk about. So as I mentioned, it's tough to communicate. And I thought that was just an experience that I had, but it turns out it's the same experience that a lot of other people within Auros that were trying to communicate about requirements had. And so one of the things that we ended up doing is, based on our collection of experience, we started to really define the kind of creating categories for the types of requirements that we're being asked to consider, and the types of requirements that we think are a good fit inside of Auros IQ. So the breakdown of the 4 types of requirements that we've came up with are listed here, and I'm going to kind of go through each one independently. And I'm going to start with greenfield engineering. So this type of requirement, greenfield engineering, we call it flow down. It's more of your traditional type of requirements, cascading approach. Very useful in new technology development. So kind of an example of what I mean by that, we have a little thing up there that says rockets, right? So an example of this greenfield kind of flow down information is, let's say you're tasked with creating a new rocket. That new rocket has to carry a certain amount of payload into orbit. Based on that requirement of getting that amount of payload into orbit, you have to have a certain amount of thrust. Based on that certain amount of thrust, you have to have a certain type of engine. Based on that certain type of engine, you have to have a certain amount of fuel, and it goes on and on and on and on, right? A cascade of requirements. And it's very common in these types of new development workflows. So one of the things about these types of requirements, they tend to be very specific to that project. Very little reuse, right? They're non-recurring is the term that we have listed there. And because of that, because they're non-recurring and there's very little knowledge, like kind of a knowledge workflow related to them, it becomes more of like an analysis workflow. There's really, these type of requirements are really tough to kind of think about in a normal knowledge-aware way, because they're not reused, right? They're not often reused. And so for these types of requirements, which in the beginning we had a lot of conversations with people that did these type of requirements, Auros really wasn't the best fit. Can it do it? Yeah. Is it designed for it? No. And there's a number of other applications that are specifically tailored to these types of system engineering, traditional requirements management approaches, lots of other applications that compete for these workflows. So let's kind of eliminate the greenfield. Similarly, let's kind of go over to the far right, software. Very similar to greenfield engineering. Very little reuse again. These type of requirements tend to be like, based on this input, this output needs to be X, right? That kind of input. Again, not much of a knowledge-based process there. And similar to greenfield engineering requirements, there's specific applications that handle these really well. So application lifecycle management tools take these type of requirements, integrate them into development systems and test suites, and they work really well there. But there's 2 in the middle that I want to focus in on, because these are the ones, when I was interacting with customers and getting them excited about the opportunity to be more knowledge aware, these 2 in the middle tended to be the ones that people got most excited about. So I want to explain a little bit about them. The first one I want to talk about is externally authored. Now, greenfield could also be externally authored. What makes this one different, right? Well, the difference here is these type of externally authored type of requirements, they become very recurring. They're not just, we use it on one project and that's the only project we're going to use it on. We want to reuse that information. But how do you do that? Because it's the same top level requirement that you need to meet. How is that different from the first one? And I want to explain it like this. So as an example, a very generic example, so the first example I had a rocket, but let's say in this one, you have a requirement that you get over and over and over based on your project or product. Doesn't matter the customer that you have or the project they're doing, you have to meet this certain requirement. Let's say that certain requirement is that you have a maximum weight or mass that you have to meet. So every project that you do, you're going to have that same requirement. There's a certain maximum weight you can't go over, otherwise you're not in compliance with that rule. And in one way, one thing you could do is you can say, well, for every project I get, for every customer I get, I'm going to author that specific requirement. You could do it, be very inefficient, right? You'd have a tremendous amount of redundancies. You're managing that same requirement over and over and over again, and the only thing that's different about that requirement is that value, right? Each project would probably have a different value, a different mass value that you can that you have to meet. But in this case, if we take that same requirement, we author it once, model that requirement, and use that requirement across projects. Instead of taking and creating a unique one, we take an instance of that same requirement, use it on our projects, and apply a value to it within the project. Then we're now becoming more knowledge aware. Then we can start reusing that information, learning from it, getting that model data footprint of how that requirement is being used. Similarly, with item number 3 here, internally authored, kind of in the same vein, a little bit different. So in the externally authored, those type of requirements usually come from the customer or maybe a regulatory framework that you have to meet. And internally authored, these are all within your organization. These are the controlled crowdsourced information. Jeff mentioned this thing about communities. This is the community. This is your own internal information, own knowledge that you're capturing in an effort to apply that learning against the externally authored requirements. We like to call these proxy requirements, and we see this a lot, right? Especially in automotive, it happens quite frequently where you have a certain product that you're going to launch into the North American market, and you have a certain set of requirements you need to meet. But if you take that same product and go into Europe, there's a different set of requirements. Instead of validating the North America and the European market, you create a proxy requirement that satisfies both, and then you design to that particular requirement. In that case, we also have a lot of reuse and the ability to use in a more knowledge-aware approach. And the real magic happens is when the two work together. The information coming from top down, the information flowing from bottom up, those relationships get managed automatically. I'm not going to go into a whole lot of more detail on that because actually Jeff is going to provide quite a bit more detail later on today on that type of a concept. So that's kind of a little bit about requirements, how we break them up, what's valuable to us, what works well in Auros IQ and what doesn't. So these externally authored, highly recurring, and internally authored, highly recurring. With requirements, we also have a maturity model. Our maturity model is a little different. So our continuum starts with customer-centric approach versus a knowledge-centric approach. And I'd also argue it's also more of a model-based knowledge-centric approach. But regardless, in the customer-centric approach, I want to give you kind of a little bit of story, kind of going back to my interactions with people about requirements management. When I interacted with groups that were doing the externally authored and internally authored stuff, or attempting to, and they fell into this first category of using kind of basic documentation, using the original sources of the requirements to work against. So they're communicating that information out. This particular group was very forthcoming on the pain. Mikayla mentioned, what makes a core use case, and the customer can identify as the pain. In this case, whenever I worked with this group, they're very candid. We get all of these different sources of requirements and all these varying formats, all these different file types, and I'm trying to synthesize this information, trying to get it to the right people, get it applied, collect information, and it's very daunting. This group was very willing to talk to us. The next group I met with are teams that tried to solve the problem, and what they ended up doing was creating a very highly sophisticated, complex Excel spreadsheet. Better than using nothing at all, but one of the key differences in interacting with this group versus the first group is this group wasn't forthcoming at all. Actually, what I internally, what I used to call this group was a proud parent group, because that Excel file that they created was like their baby. And you couldn't get them to say anything bad about their baby. Actually, quite the opposite. When we would go into those meetings, they would say all of the benefits. My Excel sheet does this, it helps us in this way, it's great in this manner, and they would go on and on and on. And frankly, throughout that meeting, I'm wondering, why am I here? I think they're convincing me that this is a better approach. But ultimately, what always happened was they would get so eager to show their Excel file, I would ask them to do it. They'd open it up and show how it's all great and everything it does. And every single time throughout the conversation, it transitioned from how great it was to the amount of effort it took to create and the amount of effort it took to manage, all the energy, all the time spent developing it. And once we got past it through that phase, then it became, as every parent in here would know, one of the things that started to happen was it wasn't just all about all the great things it did, but it was all the grief and frustration when it didn't behave the way you expected it to. And then once they started talking about all the bad behaviors of their Excel-based process, then the floodgates opened. Then I heard all the bad stuff about it, and then they became receptive to the message of using a more knowledge-aware approach to handling requirements. Our next group is the group that uses traditional requirements management systems, things like doors, those type of applications that do greenfield engineering and even sometimes software engineering really well. So when we meet with these groups, typically we are meeting with teams that weren't necessarily the greenfield part of the workflow. They were the part of the team that was forced to use these type of applications that maybe they want to become more knowledge-based, and either these systems either wouldn't allow them at all to do it, or their capability within the tool sets didn't allow them to do it. And so these type of teams ended up becoming more receptive to a knowledge-aware approach because of the availability to model your knowledge and process that knowledge throughout different projects. And lastly, what we ultimately try to get them to is a more knowledge-aware approach, a more model-based approach where we can systematically align those external requirements to the bottom-up, the controlled crowdsource type of requirements, and kind of get to all of the benefits that Jeff has talked about, Mikayla has talked about, all of the model data footprint information that's available once we start creating those models, using them across project, getting all the trending. So with that is requirements.
So the next use case we'll talk about is design review. Design reviews are evaluations that provide feedback, identify potential issues, and work to improve an overall design against its requirements. I'm not going to go into too many details on what design reviews are because in general, we see that people are pretty familiar with them, but we'll talk about the maturity model and the different versions of design review process that we see. So as a design review process matures, we see that it goes from event-based to more of a continuous process. The first stage being ad hoc design reviews. So there are informal reviews conducted once a risk has been identified. You can get value out of this process, but it's inconsistent and unstable. If you add standard timing, you can reach a meeting-centric state. So now you have a planned date that you're going to do your design review. You're not waiting for an issue to arise before getting to it. And a cross-functional team meets to identify risks. This method is more stable, but the content that's discussed is dependent on the people in the room and their ability to recall their knowledge and identify risks. The next stage we see groups doing is meeting-centric, but with a standard agenda. So this is one step further. The cross-functional team meets at a time predefined by the product timing plan they're working towards, but now they're using documented criteria to evaluate the design. This method is stable and consistent, but it's more of an after-the-fact review, and you may be too late in the process to identify some of the risks. The final stage that we like to see people in for design reviews is knowledge-aware. So this is a continuous cross-functional evaluation that occurs based on dynamically provisioned knowledge, which enables real-time reporting and look-across. And next we have SmartCAD.
We went from my least favorite to my favorite. And for all of you that have been to this conference before, you know how much I like this one because I've presented this topic many times. So kind of before I get started, let me kind of state the goal of SmartCAD. Actually, just saying SmartCAD, I just love it, right? SmartCAD, it's kind of the whole essence of knowledge aware. But our goal for SmartCAD is to provide a single source of truth for lessons, standards, requirements that inform every model within CAD, resulting in reduced effort levels, improved communication, and expanded opportunity for new learning. So that's our goal for SmartCAD. Kind of looking at this representation of our use cases and all the dotted lines between it, when we start talking about knowledge aware and informing, making decision making, provisioning knowledge into the flow of work, this is SmartCAD. This is where all that other work results in. So kind of get in a little bit about SmartCAD. We also have a maturity model. Kind of going from a more manual-based approach to applying knowledge within a model to a more model-based approach. In the more manual sense, what we see a lot is people relying on the experience of their designers. Happens a lot. Actually, we usually don't talk to this group when they have highly experienced individuals working in their modeling environment. We typically start working within this group is when the team expands and they have less experienced people, or they're forced to contract out some of that work, and they want to start to infuse knowledge into their workflow process. Now, these groups typically have some sort of kind of design guides, those kind of things, but they're all passive. Kind of read them at your leisure. They're not really part of the workflow. Kind of augment that when kind of go beyond just the, hey, we have a design guideline, we have some new individuals who are not as experienced. What a lot of groups will try to do is kind of backstop their experience by creating check sheets. Knowing that if they create a design and there's certain critical features or certain types of design standards that need to be met, they'll create a check sheet, typically in Excel, that after a model is completed, you go through, check the boxes. Works. If that's all you have, it works. This kind of group typically gets us in, talks to us, again, try to get more information into the flow of work instead of relying on these particular check sheets. Check sheets tend to be very limited on what they're checking. And these design managers, engineering managers know there's a lot left on the table. Then we start to meet with groups that like to hard code knowledge into their parts. Nothing wrong with this. Actually, I think it's fantastic that they do this, to a point. With hard coding information into models, that information is pretty much stuck in whichever CAD application, whatever platform you're in. As we know, especially in knowledge aware, that knowledge that we're provisioning into these models is also useful elsewhere, right? Not just in that CAD model. We have a number of other workflows, lessons learned, requirements, design reviews, where that information could be also useful, but it's stuck in a CAD model. It's very CAD specific. It's hard coded into these tools. So what we like to do is get them to a more knowledge aware approach, right? We want to be able to dynamically provision knowledge into parts and assemblies based on context of that model, right? So kind of going back to the nav app, what am I working on? What is this model? We can use the attributes of that model to understand what they're doing. Understand what knowledge needs to be provisioned into that model to inform those designers to make better decisions, to establish that model data footprint, understand why trade-offs were made. So with this knowledge aware approach, one of the biggest benefits that I see and I always talk about is that it's CAD system agnostic. It doesn't matter that you use NX. Doesn't matter that you use CATIA. In a lot of cases, a lot of you have multiple CAD systems. So if you're doing number 3 hard-coded template parts, you're hard-coding that information in NX. You're also hard-coding it into CATIA. If things change, you got to go change it in both places. Once we get to a knowledge-aware approach, that same knowledge is as useful in NX, CATIA, Creo, SolidWorks, AutoCAD, whatever it happens to be. It's CAD system agnostic. You're using the gold source of truth to inform that model. A little bit more about SmartCAD. I wanted to include this because some of you may not know what the Smart CAD connector looks like. So this is, Jeff talked about our knowledge layers, and there's a commercial side to it. This is an example of the commercial side. We create a CAD connector. The same interface that you see here, or very similar, is available for all the major CAD systems. And I just kind of want to go back through what these connectors do. The first thing is drive and check parts against requirements and standards. So drive and check. So the ability to push values into a model, have that model react, get a reaction from that model, understand what happened in that model, or just simply check. Like compare that model to a set of standards or requirements. It connects that model to authoritative sources of truth, right? Without copies, that's a big thing, right? It's check sheets, we know, get copied over and over again. Even if you say, you have a master check sheet, your staff is going to create copies. They end up using copies. When we get to a more knowledge-aware approach, and we use that knowledge service layer, we're connecting these models to the authoritative source, directly to those models of knowledge. Number 3 provides automatic reporting and conformance to stakeholders. Now this one, I really didn't value a lot until I started working with teams that had very limited licenses to CAD applications. So the cost of CAD applications and licensing is very high, limited amount. Some managers and supervisors don't get licenses to go in there and check on the models. So being able to provide a representation of the health of a model or the risk associated with a design outside of CAD is extremely valuable. And these CAD connectors do that automatically. It's that persistence of value that Jeff talked about that we can see and share with stakeholders. And the last thing, also in that same vein, is creates parameter analytics and insights. It's that model data footprint, right? Knowing that this knowledge was used on this particular model, what the values were, what it changed to, the reactions to that model, all are captured, and we're able to learn from it over time. So one more thing I want to talk about SmartCAD. It's a big topic for me. Similar to having a maturity model for where are you, what do you currently do, we have a maturity model for teams that implement SmartCAD within their organization. So I kind of want to just go through this quickly. It's 3 stages that we go through. We have teams start out with. The first stage is dynamic parameter sheets. This actually, the first stage, we don't even recommend that you model your knowledge and embed it directly into a CAD model. We recommend you create these dynamic parameter sheets and verify them outside of the CAD application for 3 reasons. 1, we want to verify that the models that you've created, not the CAD models, but the knowledge models, that the strategy that's been created is sound. We want to understand that the relationships amongst the knowledge models is correct. And 3, we want to make sure all the calculations that are produced by those knowledge models is correct. We don't want to start embedding that information directly into a model, have it do wonky things, and not understand why. So we always recommend starting out, validate your process using dynamic parameter sheets. Next, we take those dynamic parameter sheets, all those knowledge models, all the parameters that are created as part of those knowledge models, and we start connecting into the model directly in CAD, using measures and relations, letting the CAD system interact with the knowledge processing engine that Jeff talked about, that knowledge service layer. CAD system has a certain size and shape. The parameters are connected to that model. If that model changes, those values change, those values get sent back, processed by the knowledge services layer, and then responses are sent back into the tool. You can kind of see a little picture there of a little pie chart of yellow, green, and red. And you get that instant feedback. And then lastly, smart parts with key parameter management. And this is where we start to fully embed knowledge models, parameters within the model, within the CAD model, making it smart. So we can drive those parts, make it react, make it comply to best practices and standards. If anybody wants any type of demo for SmartCAD, come find me after the conference.
All right, so everyone can, okay, there it goes. So our fifth use case that we're going to go over today is process execution. So we'll talk a little bit about the definition of it. It's going to be an orchestrated sequence of events or activities that are going to be designed to produce a robust outcome. So some examples of how we might do that and the components that are involved within it. You're going to have process logic. A lot of times you'll have timing events, like you'll have milestones, phase gates, stages, those kinds of things. You'll also have deliverables. Some people call those work packages. Some people call those standard work. Some people have different terms for them, right? But this idea that at these timing events, you have certain things that are required to be completed or at a certain level of maturity. And then within those deliverables, there'll be action items that come out. So you may have a challenge that you come across and you need to address that challenge, right? So these action items a lot of times are kept in like different things, that like a risk register. You might have an open issues list. And these action items need to be taken care of in order to fulfill the deliverables. So some examples that we'll talk about, if we start to make these things like real in terms of what people do on a day-to-day basis from an engineering perspective, the product development process is going to be one that's very aligned to process execution. Every organization has a product development process. You have milestones or gates or reviews that you have to go through. The next one would be something like an engineering sign-off. So this is similar to the design review. We'll have different stages throughout the life cycle of a product or of the development of a product where you have to sign off from an engineering perspective. Project and program management, those things are also going to have work that's happening across multiple stakeholders. You have timing events, deliverables, action items. Then the design review process, and then engineering change management. So there are a lot of different ways that this concept of engineering process execution can be applied. The requirements use case that Steve went into, you have a process a lot of times that you need to go through in order to manage your requirements, in order to apply them to a project. The design review concept that we talked about, when Mikayla went through that particular use case, again, you may have timing events, you may have things like CV, DV, PV, and you need to track those according to the timing of the project, right? So from a maturity perspective, we start off on the left side where a lot of process execution is going to be text-based, and then we're going to build it similar to some of the other use cases to where it's model-based. So the first level of maturity is ad hoc, similar to some of the other use cases. We have routines, we have things that people do, but a lot of the learnings and a lot of the way that that happens is based on experience, remembering what it is that you need to do. We're reliant on people to kind of manually execute these processes. So there's varied formats of information that gets captured. Like I said, it's manual and it's inconsistent. And the management of the knowledge, a lot of times, we say that there's none here. Maybe there's a little bit, but it's happening in people's heads, right? So if you go through an activity once, you may learn things, and then that refines how you do it the second time. But the actual management of the knowledge from a persistent perspective really doesn't occur. The second level of maturity is reference documentation. So we're not keeping things in people's heads anymore. We're not just communicating the processes and the ways that these things get done verbally or manually amongst people, but we're actually documenting how we expect certain things to get done. Those are static reference documents. Again, very manual, very inconsistent. You have to go find the document, then go apply. What you're actually doing is not interacting with the documentation of the process. And the knowledge management there is also pretty limited. You have the information, but it doesn't necessarily get refined over time. The third level of maturity, and this is where we see a lot of customers that we work with, is project templates and standard work. So you have maybe a diagram of your process, then you have checklists for the deliverables that happen at the different timing events. Those checklists then get completed. You then have information or work that's happening in other places that are going to fulfill the things that are within that checklist. So the format is going to be template-based activity lists, which is good because we're starting to apply things consistently across instances of the events. But when we start talking about reporting and insights, a lot of manual work has to happen. You're harvesting information from Excel files, harvesting information from PowerPoint, Word documents, wherever the information is, and putting it into reporting mechanisms. In addition to that, the knowledge management, There's document control, so we have the ability to refine things, but the propagation of the information, the change management still becomes difficult and requires a significant amount of manual effort, right? So when we then go into the knowledge-aware maturity level, we're going to be able to have bidirectional model-based processes. So you can define the process, but then it can also be executed in context of a project. You're also going to be able to facilitate reporting and insights on demand in real time. So we'll communicate things as the work is happening. It gets communicated back up the chain, down the chain, so that we're able to report in real time as opposed to taking all that manual effort to produce reporting mechanisms. And then from a knowledge management perspective, there's this single source of truth. So Steve talked a little bit about that with the SmartCAD and the requirements, where we're getting information captured and managed in one central place, and then those things are being provisioned into the areas that we need it. And then the comprehensive change propagation. Again, we're going to be able to, when we make a change, communicate that to the places and the people who need to know about that information. Okay, so we're going to take this and we're going to go a little bit more into a specific example. So we gave all the different examples at the very beginning before we went into the maturity model of how engineering process execution could be applied. Here we're going to take the product development process. We're going to explain a little bit about some of the challenges that exist here in this particular use case and how engineering process execution in Auros can help you address some of those things. So when we start with product development, we talked a little bit about timing events. We have these timing events. We're then going to produce deliverables at each one of these timing events. And at those deliverables, there's work that needs to be done. There's multiple stakeholders who need to complete that work. The information for what they've done needs to get back to whoever's tracking the program or the project, right? And then we introduce this next level of hierarchy, which is in order to complete those deliverables, we now have the standard work. That standard work a lot of times can require support activities. So we've got this hierarchy or this chain of information across multiple different stakeholders, multiple different contributors to the process, and the communication becomes extremely manual. It's labor intensive, and we don't do it in a way that allows us to persist. So Jeff talked a little bit about documentation versus communication. In a lot of organizations, what we see is we have these checklists, and the way that they're filled out become documentation. But the communication happens in email, in verbal conversations, in live meetings, right? So what we want to be able to do is start to allow people to communicate with the mechanisms that define the process in the context of their project or their program, and that allows us to produce this data footprint, right? So we can have the communication, the decisions that were made, they're captured in a normalized way, and it can facilitate a lot of this activity. So if we start with the current state, which is what we see a lot of times, we've got this hierarchy of information, this manual communication happening, and so far I've only talked about one project, right? As you go to organizations, people have 10, 20, hundreds of projects going on. So we take that problem and we multiply it by however many projects you have. So now the problem becomes even larger, and as we're trying to do things like continuous improvement and manage knowledge and improve the way that we do our business, it becomes very difficult to do that because we're managing all of this quote unquote non-value added work of the communication, the manual reporting, that kind of stuff. So if we can start to capture information, facilitate real-time reporting automatically, and then do that in a way that allows us to harvest the data and gain insights, we can reduce the amount of manual effort that it takes to continuously improve and to manage the knowledge, identify opportunities where maybe we have a gap. It's difficult to do that with the Excel-based or the document-based approach because you have to mine all that data. You have to be in all these places. So this kind of lays out the hierarchy of engineering process execution in the context of product development. Now to tie it to, I missed a couple. On top of those things, you also have your action items list, which go all the way throughout this entire hierarchy. And then we have this idea of lessons learned, right? At any point in time, you can learn something and you might want to curate and improve that knowledge. So now we have this hierarchy of information. We have these activities that are going through all of the different levels of the hierarchy, and it just increases the complications or the complexity. So to tie this idea back to the core use cases that we all had, that we talked about before, in these different levels of the hierarchy, requirements a lot of times is one of the deliverables. The design review is one of the deliverables. SmartCAD is a support activity for the design review, which boils up to the milestone. And then lessons learned is this unique use case for us, a core use case that goes through all these different things. But the enterprise capability allows you to take not just the core use cases, but also things like a DVP&R, like a cost study, like a risk analysis. You can manage them in a central location, get the benefit of the communication up and down this chain, and the continuous improvement and the knowledge management aspect of it. So that's where all these things kind of fit together to get to the enterprise capability.
So as Josh explained, when you manage knowledge information in one location, you allow it to flow through the use cases and enable that enterprise capability. Auros enables you to actively inform every model. So SmartCAD is one example of an area where these roads start to intersect. You can see the application of requirements and best practices in the design and the model, which moves the application of knowledge further left in the development process. So there's more value in the collection of an interaction between these use cases than there is in any one individual use case on its own. Are there any questions?
I don't know.
Oh, you got them?
I'll talk loud.
Hi, Bill Kokachek from GM, and maybe more of a, Josh, could you put your last slide back up, please? Maybe more of a comment based on our experience than a question, but this is a very compelling, I mean, we at GM with Susan and I and our bigger team, because we've had a lot of meetings, and we used this idea of putting all of our basically checklists for an entire design and build and preparation of a set of tooling, all the different subsets of that, zones, you know, bigger sections like underbody, uppers, and so on. So we have all those checklists, and it's a very compelling idea to break all those down and put them all in, except that it becomes the value becomes the significant few, and you have such a giant volume of the insignificant many of all of these checks. And so what we find in getting adoption is that the people that are doing the jobs really struggle with the extra work that it takes. Sure. And it's almost like if we can identify the insignificant or the significant few and spend less time on the insignificant many, yeah, they need to be all checked off. But so the whole point being that the scope of what you decide to do here is a huge factor. I mean, if you try to bite off an entire section of the organization and say, this whole body engineering all the way through tools on dock, we want to try to put all of that in. And it was too big for us, right? And so we ended up having to scale it back. You know, it's not that it's too big, it needs to get there eventually, but somehow we need to figure out, we need a lower level of detail that gets put in, and yet at the same time, all those checklists need to capture that all of that higher level of detail of activity has been done. And that is, I guess, just my experience.
Yeah, I think we see things like that in a lot of organizations. One of the things that you talked about, Bill, was that you have checks and they happen multiple times. A lot of times what leads to that is the low level of confidence that having it in one place is actually going to make sure that we're avoiding the risk, right? So we end up having multiple checklists that don't really talk to each other, They contain duplicate checks because we have to make sure that we did the check, so we put it everywhere. So when we start to do something like this, I agree with you, you don't go for the entire process all at one time. Jeff talked about this a little bit earlier. Start small. So this is a concept of where you can eventually get to and you can achieve the enterprise capability. But if you have challenges in design review, it might make sense to start in design review. Or if you have challenges in SmartCAD, it makes sense to start in SmartCAD. It doesn't mean you can't build eventually to get to this point. But absolutely, if you try to start with the entire thing, there's a lot of change management, there's a lot of complications. When you go through this knowledge-aware process, it allows you to reduce these duplicates because you start to gain confidence in the fact that, okay, we're checking it here, and I know that it's not gonna get down to the later part of the cycle and like be overlooked. So I would absolutely agree with you that it's a lot to do in one file swoop. So we can start in one of the areas and kind of build to this enterprise capability.
And we thought we were scoping something
Right.
that we could manage. I mean, we understood that scoping is a big issue. I mean, you are familiar, you were there. So, but what it turns out is the scope was too high. I mean, there was too much. It needed to be smaller. And, you know, to take advantage of the real power, we almost need the bigger scope. That was our idea. We want to take advantage of the reportings, the read across of all the programs. What about all our statuses of all our ongoing programs with regard to some specific item that now we can read across because we did this whole full implementation. So we're looking for that power, but we had the issues that, and it stalled. We hope to get there someday, but you know, other things have gone gangbusters, and hopefully some of those will get highlighted today. You know, some of our lesson learned activity, but that was just mine.
Yeah, and that's one of the things too that the core use cases can help with. Like if you're debating on whether to start with a risk analysis or design review or risk analysis or requirements, the core use cases are going to be able to provide value beyond some of these other use cases because we're uniquely solving problems in those areas. So being able to start in a core use case may get you to the point where you're able to show that value before you get to the full enterprise capability in a more meaningful way. Yeah.
I guess I have a follow-up question, listening to what he was saying. Is there a way to make certain items mandatory versus recommendation? Is there a way to prioritize? Because if there is a way that we can do things, maybe when we are under time crunch or certain, you know, situation, let's consider these 3 out of 5. These are the highest priority. We need to consider those, and then, you know, or you know, however you can make it a little more robust that way. I don't know if it's possible with this.
Yeah, there's ways to manage the different levels of requirement on what it is that you need to do or not do. So there's ways you can configure the system to categorize information so that you know that these 10 are the things that you absolutely have to take into account. These 15 are recommendations, for instance. So we have those kinds of features in the product, and it's just a matter of what Jeff talked about earlier with the no-code solutions. You're just going through and configuring it based on the needs of the group.
I have a question for Steve.
Oh, I'm not taking questions.
No?
Not from you.
When you were talking about you started with talking about requirements.
Yes.
And the use of Auros and requirements. You explicitly talked about greenfield activities.
Yes.
And I had 2 things to maybe ask. One is that most new activities, even new rockets, seem to have components that emerged from past propulsion systems.
Right.
So they only have proportionally some small proportion of greenfield truly new development based upon large bits of old or existing know-how.
Yep.
That's one. The second is that should it even be purely greenfield activity, wouldn't there then be a follow-on other activities at the same organization that would then benefit from the lessons of this one?
Sure.
Which then, oh, sorry.
No, go ahead. No,
That's it.
sure.
That's what I wanted to bring up and see what you thought of that.
Yeah, absolutely. So when we're talking about greenfield, you're absolutely right. New products aren't entirely 100% new, right? There's core portions of those products that are reusable. When we talk about the greenfield engineering and this idea of limited reuse, we're saying that because these things are new, because these requirements only are going to apply to that one product, that one project, and maybe that's the only project, the only rocket they're going to create. There's very little recurring knowledge there that's going to be applied. And what we tend to see happen with these type of requirements is that these type of requirements are often used in the systems engineering model, right? They're embedded in those models, validated, verified within system engineering tool sets. And it's not, I mean, as you know, like Auros can do some of that stuff, but there's other tools that handle those use cases better than what we're currently doing. Not to say that we couldn't at some point in time, but right now we're not focused on those type of requirements.
Anything else from the crowd? Got
Yeah,
a
there's
couple more.
Yeah.
We do have several through the app, so if we don't get to those in time for this session, we can. These guys are approachable during the break for them. Go ahead.
All right, so Steve, I was going to talk about the greenfield too, because I still feel like you still could use Auros because there's basic engineering principles that must be answered through any development, right? Sort of like risk analysis, failure mode analysis, right? What are your requirements? There's key questions that you could ask for both, like your ones that you didn't say that you could potentially put in there along within a regular product development cycle, because even if you make changes, if you're modifying something, there could be something new in an existing, development that you are, it's, hey, I know I'm an expert, blah, 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 but there's still stuff that you could ask in that kind of thing to guide the process. So like what you were saying is, you were saying like, okay, do you understand your requirements? Do you understand your guidelines or best practices or anything to help that development, right? I think you could set a standard set of questions that would be sort of maybe not telling you exactly to what you want, like for your smart model or your smart CAD, but it could still be a guiding thing, because what I typically find is engineers don't know what they don't know, so let's go ask a question. Right?
So you're absolutely right. So in that greenfield example, I was specifically talking about this cascading effect of high-level requirements. And kind of what you're mentioning is the application of those internal requirements applied to those greenfield high-level requirements. And that is the stuff we definitely focus on. We don't exactly align them all together, very pretty, because in a lot of cases, organizations are using tools other than Auros IQ to manage those greenfield requirements. So it's a little bit tougher to do that knowledge provisioning, that knowledge-aware approach on information that's in two different systems.
Steve, so maybe I was taking down the wrong pathway here. I may have overlooked you were weighing more heavily on the requirements part, the requirement traceability.
Yep.
Not so much the knowledge gain, but the experience of doing that.
Yeah, a lot of that will end up being in that internally authored stuff, right? It's that controlled crowdsource. So the experiences you have trying to achieve those requirements, you're just going to capture that. It's going to be authored in a different way.
I think I'm going to hit about 3 birds with 1 stone on this one. In the CAPEX process, the criticality coming from DFMEA, you set your criteria set in there, and then as you're doing your assessments, the Kelsey's one helped set us up over at an alpha. The engineers know that they have to hit the criticality of 5 is critical. You can go through and you can hit all your 5s in that process and maybe skip the 1s if those can be even set through a deviation. So in the setup process, you tell the engineer, this is a must have, and this is definitely 100% needs to be completed. One more for Steve.
Yeah.
You had a slide on there about the parameter sheets
Yep.
for is that the same as the parameters that are set up in your CAPEX?
Exactly the same.
Exactly the same.
Exactly the same. So those parameter sheets, when you're looking at your assessment controls, there's 2 different views, multiple views from the assessment control. One of them being that line item sheet where you kind of see the details. Another option is the parameter view. That is exactly what I'm talking about. Kind of stripping out all those details and just getting directly to the parameters that influence the design of that model. And it's on that parameter sheet, it's really when you can see the relationship. So once values are published to that parameter sheet, you can see the reactions throughout all the other models.
Any other questions? All right, we're perfectly on time. So thank you, Steve. Thank you, Josh. Thank you, Mikayla. Again,